like a blower right outside my window. It's going.
That's funny. Yeah, well, so it's funny you bring up the machinist handbook because I got one my first job too. I've got the big boy, the big 26th, the full size edition, right? The big guy, and
yeah, I mean you have the huge book. I've got like the pocket thing here. It's kind of a little bit smaller than what yours is. Looks like we're live there, Steve.
We are, yeah. Yeah. Well, hey, yeah, we're live. Jeremy and I are just having a conversation about the Machinist Handbook. I don't know if any of you guys that are on have one of those, but yeah, it's I grabbed mine on my first job. Actually, it's funny because I pulled it out. I still have like all the little tabs referencing like where key seats are and steel gauges and all the stuff that I was completely ignorant to when I got into my first job.
Yeah. Hey, Steve, that's a great question for the people on chat. What version of the Machinist Handbook do they have? You think that's a question we should be asking the chat?
Definitely. What version or do you use something else? Do you use, I think they actually may have an app now. I don't know if it's an official, but yeah. What version of the Machinist Handbook do you guys have if you're using one? So
you were in industry. So I had to reference that a lot too. The sheet metal gauges, that's a good spot. The sheet metal and wire gauges, like some people seem to think that gauge means gauge. They're different, right? For sheet metal and wire.
Definitely. Yeah, they're definitely different. And yeah, I think it was one of those things where after a few conversations with the guys out on our shop floor, I was like, I probably need to bone up on some of this. You know? So, but that was actually kind of, I don't know what your first job was like, but mine was great because we were a startup and a lot of the stuff that I was designing, I was actually out on the floor helping to build then as well, which gave me a lot of like School of Hard Knocks education.
So my second job I had when I started, I had to spend 3 months on the floor before I could even start designing. We did automation equipment, and that's like everybody who comes in there as a machine designer, that's what they want them to do. I mean, I did some CAD work, but I had to spend a lot of time like working with a machinist, building machines, figuring out what are like the problem areas, because apparently, you know, they want to make sure that the things go together well. And we recognize that pain.
It helps. Hey, I want to shout out, hey, Todd, welcome. Todd says he's got one on his desk from 1956. You might be the winner right now, Todd, related to the oldest version of the Machinist Handbook. For those of you that are joining, Jeremy and I are just kind of having a conversation about our first jobs and how important the Machinist Handbook was to those. So if you have one, go ahead and put it in the chat, the year or the version that you have. You know, Jeremy, about machines going together. I built one time that perfectly worked in CAD. Like there was no interferences. It was great. Went out to the shop floor. They started building it, and one of the guys calls me out, and he goes like, listen, it's great that all goes together in CAD, but I can't actually get a wrench in here to tighten the bolts the way that you've designed this. I was like, that's a good point.
I had a production line for a center console for a vehicle, and it had this crazy cam mechanism on the bottom of it. It was basically a laser cut profile that was meant to raise. It lifted parts up on a pallet that moved down a line. But when you have to like laser cut those profiles out of like 15 different pieces of sheet metal, you start getting this weird tolerance stack up over time. And that was like, it was learn to shim.
Yeah. Well, burns are interesting too, because I was fairly new to SolidWorks at the time, and I was getting some cutouts made, sent the DXF off. It comes back and they're like 1/8 the size that I was expecting.
Oh.
And I was like, oh, this doesn't export 1-to-1 automatically. There's an option I forgot to check. So I had a lot of little pieces that sat on my desk for a while.
Like a miniature version of the machine.
Yeah, it was fun. But hey, again, hey guys, welcome to Solidworks Live Design. We are just having a conversation about our first jobs and some of the school of hard knocks things that we learned along the way as designers. Let us know in the comments if there's some fun story that you have related to the first time that you started designing or your first job. We'd love to hear about it. Hey, Ray Folks, welcome. Nice to see you in here, Dallas Salad. He says there's a 13th edition from 1946 on eBay for $10. That's probably a steal.
Yeah, I'm going to jump on eBay if that's not going after this live design.
Yeah. Well, hey, Jeremy, I think we can kick things off. I want to welcome everyone to Solidworks Live Design. I'm going to be your host today. My name is Steve Fick, and I have the absolute privilege of being joined by Jeremy Regnaris, who, Jeremy, you're obviously not new to this in any way, but I'm excited that you're going to actually be driving SolidWorks for us today. And this is exciting because I always learn really interesting things from you when you present. So what are you going to be presenting on today?
Well, Steve, we're going to be talking about patterns. More specifically, we're going to be solving a design challenge: how to design this timing chain on my screen using a variety of different patterns. And your first response might be, well, why don't you just do a curve-driven pattern or a chain pattern? We're going to talk about some of the hiccups that some of those types of patterns have. And more importantly, we're going to be looking at this like slack that we have to put in here. Now, we're not going to get into the debate of belts versus chains in an engine design, but I want to show some people were a little bit surprised about like how a timing chain in an engine works. There's a tension side, and then basically there's a slack side on this. So I'm going to pull up a couple images here for reference.
So Jeremy, real quick, before you do that, I just want to encourage everybody. I think there'll likely be a lot of questions that people have as we go through this. So I just want to encourage everybody, put those in the chat. I'm going to do my very best to interrupt Jeremy at better, more opportune times than I just did. But we'll do our best to make sure that we get those questions over to Jeremy. So take advantage of that.
All right. So if you're not like a gearhead or you don't look inside of an engine, what you run into is to make sure like your timing chain is always tight. You have basically the rotation of the engine, and then you have a fixed side, which is pulling tension on the camshaft sprockets. And then to deal with the slack and the even number of chain links you might have, you have a tensioner on the opposite side of the rotation here. Give you a couple more really cool examples of this. Here's a really cool dual overhead cam design. This one actually takes timing off of the crankshaft out to two auxiliary sprockets, and then they kind of drive it here. But in all these cases, one of the things you'll notice is we kind of have this tensioning that needs to take place here. And this is fairly representative of what we're going to be designing today. Now, we will not be putting a guide or a tensioner on this side. We'll be pulling this taunt along this side, and we'll be building our slack in there. And this creates one of our first design challenges we're going to face in here. Now, where are we going with this? Well, what we want to do is we want to get the timing of all this to work, because people really like in SolidWorks, you can do really cool motion here. You'll notice everything works here. We have a chain that's driving our cams. Everything's in time. They're at the correct ratio. You can kind of see here, we get, so how do we get that motion in that chain? How do we design that chain? There's a couple different challenges we're going to look at. And believe it or not, we're not going to start with this assembly of this chain. We're going to tackle this two different ways, because there's really two different ways you could approach this design. One, doing it all assembly based like this. But the other way is, how are you purchasing the chain? Is it a single part number? Well, then does it make sense to just do this as like a multi-body part right here? And we're going to start with this. We're going to start modeling this chain as a part using a variety of feature patterns. Then we're going to actually leverage some of that information that we get there to design the the moving version of this. So why don't we go ahead and dive in? I'm going to close this. We're going to start with a fresh assembly here. And I'm going to do, I have this set up a little bit wrong. We're going to mix some things up here because I want to talk about designing things kind of in the right orientation, right? So we have all these components. They're kind of moved in weird spots. They move independently. So Steve, you can see we have a rotation here on our crankshaft. We have each camshaft kind of rotates individually. You can see I have some cam mates there on the tappets for the valves. One of the first things we want to do when we think about aligning everything and getting it all set up right is getting it in a home position or a fixed spot where we know where every component needs to be at a certain point throughout this rotation. In an engine, that's called top dead center. That's where cylinder number 1 is at the top, and it's right before intake, before the intake stroke on a 4-cycle. So
right. So you're saying, you know, like a lot of us, we like to, it's that urge to grab a part, start rotating it, moving it around because we can, but how do we get it right back to where we actually need it to be for what we're designing or what we're doing?
Absolutely.
All right.
So top dead center for this is with this first piston all the way up at the top of its stroke. That's why it's called top dead center on an engine. So I have some mates here that I'm just going to unsuppress for time's sake. But what I've done is I've used favorites. This is a good way if you need to turn things on or off. So you saw me with motion before. I just turned these off. I could always turn them back on. I have a parallel mate that I made from the top plane of the crankshaft to the top plane of my assembly. This is going to, so no matter where this is going to set that at that top dead center right there. So now these components can't move anymore. Now, what I need here is I need this camshaft to be right before the intake cycle starts. And I have some mates here, but I might as well show how I did these right here. So what I'm going to do is I'm going to grab, because one of the things that's interesting about this camshaft design, if I hide these two pieces, is they're not straight up and down. So the first thing might be, well, don't you just want to go top to top and make those parallel? Well, now you can see my timing is off. That cam actually needs to be advanced several degrees further of that. So let's undo that. What I actually want is I want that top plane to be parallel or perpendicular to the direction that this valve is going. So in this case, what I'm going to do is I'm going to just make that parallel to that top of that valve tappet. Now, does that make sense to the audience? Like why I've done that? Like, to the valve and not to the assembly?
Yeah, let's ask him if this is making sense. Give a thumbs up or let us know if you have questions. I think one of the questions that did come up is you're just, to your point earlier, you're just using mates. You're not using Instant 3D or anything like that, correct?
No, we're going to be using Instant 3D is more when you're creating features in a part, and we will be leveraging Instant 3D quite a bit. This is just me grabbing these components and moving them around. And basically I've created these mates to get, so you'll see in the tree, there's no dashed lines in front of any of these components. They're all fully defined. Now I'm going to remove these two parallels that I just created.
And Jeremy, how do we add to favorites? Just real quick, you showed the favorites. I think that's an amazing tip. How do we get those there?
So I have a couple mates that I need to reference, right? So I just suppress those and I want to access those. So if I dive into my mates right here, I have a mate here. I have this one called crank lock, and then I have these two parallel mates here that kind of lock everything in place. Those aren't the ones I actually wanted. Where did they go? Let me see where these are really quick. Well, an easy way to do this, right, is I'm going to grab this component, this camshaft, and I'm going to press my D key, and I need to find that parallel mate I just had. So before we get to adding to favorites, I do want to show this. This is pretty cool. You have this ability from breadcrumbs to go grab these mates. There it is. Now I can see where it is in the tree. I did have the right ones. The parallel mate I did was slightly different. So to add to favorites, I'm going to grab these two mates and I'm just going to right click, and you'll see here there's an option to add to favorites.
Got it. Very cool.
So I took the long way to answer your question. Sorry about that.
No worries.
I want to make sure I have the right one there. Yeah, I do definitely have the right ones. See, there was a ton of mates in here. I didn't want to like crowd this tree out with that. So we added those to our favorites. So anyway, all of our components are locked in place. So what I want to do is I want to start designing that timing belt. I'm going to turn these cam sprockets on too. They are not locked in place. So those are the wrong mates. Let's do this.
And I think this is the cool thing about, what Jeremy's showing with favorites and folders and whatnot is that oftentimes that list of mates gets terribly long, and it is nice to have those at your fingertips, right? You're not having to scroll through or, try to find them. We're able to just add them to a favorites and get to them easily.
Yeah, so I did have the wrong mates. They were called intake cam lock and exhaust cam lock. So by the way, they were right here. They were named. I don't know why I didn't see these. One of the things I like to do is if I have a mate that I need to reference, I'll come in here and I'll press F2 and I'll rename that. That also helps with what you were talking about, Steve, finding that mate in that tree. If it's got a name, it's probably easier to find. Favorites are a really good way to access those as well. All right, so we want to start designing. Let's get into the patterns part of this. So I'm going to go ahead. So for reference, for designing this timing chain, I do have a book here. We were talking about at the beginning of the show. We were talking about the Machinist Handbook. I'm going to be designing a roller chain, and I'll pull this up on screen in a picture. So in the Machinist Handbook, under you have transmission roller chain. I'm going to be using that for all my dimensional data. So for reference, let's throw this up on screen. These are the dimensions of the chain links that we're going to be modeling. I'm going to have these over on the side of my screen as a cheat sheet here so that I don't have to be referencing the book and looking it up in a table. But we're going to start a new part. And I happen to have a part called chain template. And I just did this to save me some time in the fact that, look, I actually used some equations. I created some global variables with all those values in it as well. So maybe I can reference those. So,
I think that's an interesting point. We do this sometimes for presentations, but, part templates can store a lot of great stuff, not only equations, but like geometry and all that kind of stuff that, you can just start with right away.
Yeah, I did a live design last year where we did some spur and helical gears, and very similarly, I went through. It really talked a lot about equations, and I used global variables a lot. If you want to watch that, you can go to our live design 2020 playlist on YouTube, and you can see that video where we do a spur and helical gear there. And we really get into the equation side of this. So I'm not going to spend a lot of time on that today. I'm going to start sketching what I think this timing chain is going to look like. I'm going to draw a couple circles. And you'll notice, Steve, I'm not really locking anything in place. I'm just kind of, let's just kind of snap these together. You'll notice I'm using that really cool capability in Solidworks where when you draw a line and pull it off of an arc, notice how it captures tangency there. I'm going to go something like that. Looks sort of like what we're going to be doing. Maybe. Let's go ahead and save this, and we'll talk about how we're going to use this in a minute. Timing chain, we'll just call this live. And I want to bring this into my design. I'm going to do this just with a drag and drop to make this easy. And I'll turn on my sketches so you can see where that component is. Now, I started very loose, totally undefined sketch. What I want to do is I want to get this timing chain in position. Now, you'll notice I have a plane here that if we look at my right-hand view, happens to go right down the center line of this double strand timing chain. So I'm going to use that plane and the front plane of my timing chain to locate these two components. So we'll grab those two. And I really just like to use the pop-up menu here to mate those two together.
Yeah. So just a real quick recap. What you saw Jeremy do, he grabbed the name of the part. You can tile vertically side by side. He grabbed the name of the part. He just drag it in, and then you're just mating up the planes, right?
Right, absolutely. Perfect. And I think I've talked about this in other presentations I've given. If you have the opportunity to mate to a plane and a component versus say a face that you might delete later on, I always recommend mating to planes. Planes never go away. You're always going to have a front, top, and right plane. This works well if the plane is in a good spot in the component, which happens to be the center line down here.
That's a great point.
What we're going to do now is we're going to define this timing chain profile. And what I'm going to do is right in the assembly, we're going to do a little bit of top-down design. Now, top-down design is where we define features of a component in another assembly. And to do this, I'm just going to click on one of these sketch components, and I'm going to choose Edit Sketch. Now, Toby Schnars did a really good presentation on changing colors for top-down design 2 weeks ago. Really encourage you to go watch that. I like to keep the colors the same, and then I look at the color of the component in the feature manager tree. So here you can see it's changed to this blue color, letting me know that I'm editing it. So what we're going to do is you'll notice that on each of these sprockets, I have a circle that represents the pitch diameter. So if you're unfamiliar, a pitch diameter is really where those chain links are going to follow that sprocket around. And that's what I want to define this profile path on. So I'm going to make these two circles equal to one another. And you'll notice that that line turns black, signifying it's fully defined. And we're going to do the same thing with these sprockets up here. I have a pitch diameter, and I'm going to grab this circle, and I'm going to make them co-radial. Now, for those who don't know, co-radial is the same as making them equal and concentric at the same time. It's just a 2-for-1. I like to use it a lot because it saves me some time. And you'll notice really quickly, I have a fully defined sketch now. So inside of my part file, before I go over to my part file, I want to take a look at this. When I set everything to top dead center in the beginning, one of the things that did is it set my bottom sprocket, or where my bottom roller is going to go, right vertical with center. So I added that design intent intentionally, so that I knew that I would be able to create that there. And that's going to be important when we start working with inside of this part file.
Jeremy, real quick, we got some really great chat going on, some questions. Just to that point about going back to top dead center, you know, we had a question come in from Dallas of, is it better to use configurations or to use favorites where you're just suppressing and unsuppressing the mates? Do you have do you personally have a preference on how you would go about that?
I mean, it really depends on what you're doing. I'm going to save this really quick. I'll open up the other one that we just had up. In the beginning, I actually had configurations in there. I prefer to use configurations myself more for positional changes. Oops, I opened the wrong one there. Let's open this guy. So in this example, I absolutely did use configurations. So here I have a configuration where all of the features are fixed and I'm using a single part design, but I also have another configuration which is not named very well. And this configuration is the one that allows all of the motion. So absolutely, I always think it's a good idea. Pneumatic cylinders are a good example, right, Steve? You have an extended position, a retracted position, and then a lot of times I'll use a free floating configuration in there. So I think configurations are perfect for that type of thing.
Yep. When you kind of understand exactly what the motion is that you want, but I feel like favorites sometimes are just an easy way to just be playing around with mates, kind of until you've kind of firmed up that configuration that you're after. So.
And a few folks out there who have started using SolidWorks 2021 may be aware, maybe it was 2020, we added this other thing called selection sets, where you could create a selection set. They don't actually work with mates in 2021. That's why I use favorites. So that's an enhancement request to get submitted, that mates can be part of selection sets there.
Good to know.
Just a tip. All right, so we're going to open this up. I want to get started on the actual design. So this sketch, this is going to be our, we'll call this our chain path. I'm going to give this a name. You'll see me naming things quite a bit. One of the other things is you'll notice, so I'm going to tile, you'll see me jumping back and forth quite a bit. I drew that sketch right down the center line of this chain, but I actually want to be designing my roller on this front half here. So what I'm going to go ahead and do is I have one of those dimensions in here that we saw, our strand pitch, 0.399, crazy weird English number. Sorry, we're using inches for our international audience. I have looked high and low to find metric roller chain, and they all refer to the ANSI standards. So it kind of all falls back to these bizarre numbers anyway. Well, what I'm going to do is I'm going to create a reference plane that we're going to leverage here. And I'm just going to drag this out, some arbitrary value right here. And what I'm going to do is I want to drive that value, that offset. I want that to be half of that strand distance. So I'm going to double click on this. And we talked about this again in my last live design that I did last year. I'm going to grab that strand pitch, and I just want that to be half of that value. So I'm just going to type strand pitch divided by 2, hit OK, and then I'm going to do a quick update, and you'll see that that plane has now got that correct offset. We're going to be leveraging that. The other thing is we're going to be creating a lot of circular patterns, and I need the centers of each of these sprockets right here. So what I'm going to go ahead and do is I'm going to select my front plane, and I'm going to grab this center line, this center of the circle right here, and I'm going to go ahead and I'm going to grab an axis, and I'm going to do this 3 times. I want to create a rotational axis about each of these circles. So I'm setting myself up for something I know I have to do in the future. Keep in mind, you don't have to do this at the beginning of your design. And for those of you who are wondering how I'm confirming so fast, I use mouse gestures and I just swipe really fast. So I apologize if the people online aren't seeing me hit that OK button that fast.
Yeah, I was just going to say, you're using the S key to access it super quick, right? Right where your mouse is, and then mouse gestures to just confirm it once it's done.
Yeah, I love the S key. I love the mouse gestures for quick actions. I use them for my view. You don't even see it. I'm so used to it. Like, so there's my front view, top view, my isometric view, and I do it so fast that you don't even see it sometimes. So I apologize. I'm so used to doing that. Let's name this. Let's call this front strand center, and then we're going to name these. I'm going to call this crank center line. We'll call this
While you're naming those, just a few shout outs. Todd is saying he absolutely loves the top-down design. So you got some good thumbs up there for sure. Yeah, good job.
All right. So we've got a bunch of reference geometry we're going to make use of. I'm going to, because of time, I'm going to get going a little bit quicker here.
Yeah.
So we're going to, we're going to start by creating, I'm only going to be working on these rollers right now, kind of for the sake of time. And again, you'll see me type in dimensions. I kind of know what these are. So I'm going to do 200.2 right here. I'm just going to get that outside diameter of that roller. And, you know, if I wanted, I could get really clever here. I want these two to be vertical because I talked about that vertical alignment. Now, if I wanted to get really clever, I could actually come in here and I could do a link value. And you'll see here, I have my roller diameter. And now if I were for some reason to come over into my equations, I could change that roller diameter value right here, and it would update everywhere that value is used. Again, go back to the previous live design to take a really deep dive into that. So,
yeah. So as Jeremy started to draw this out, you know, what you're seeing is just this idea of placing those rollers on the pitch diameter, which is the center line of where that chain is going to hit the sprocket and line up where it needs to be from there. Mike Puckett is also making a great shout out here, saying that the chain and belt is actually part of the CSWE.
We're going to take a look at chain and belt here in a little bit. Actually, the assembly feature also.
Yep.
So what I've done, you just alluded to this, Steve, is if I go back to my assembly and I look at what am I actually doing? Why are you just drawing this cylinder out in space? What I'm doing is I'm creating that roller that's going to live right inside of that sprocket. So hopefully that makes sense. Why I captured that pitch diameter, because I know if I put that roller on there and I design that to the right size, that's now in the appropriate location for that. That's kind of why I've started there. And the roller is the easiest way to start. I want to take a look at, okay, so how do we pattern this at this point? And I'm going to shut off my axes and my planes. And I'm just doing this with hotkeys. This is the same thing as coming up here. I've made hotkeys, Shift A for axes, Alt A for temporary axes, Shift P for planes. So you'll see me turning stuff on and off quite a bit. And the first question I expect is why wouldn't we do this just with a curve-driven pattern? So I'm going to create a new sketch because I don't want to lose my original sketch here. And I'm going to do that. Let's create a curve-driven pattern really quickly to take a look at maybe why or why not we would not use a curve-driven pattern. So for those who don't know what a curve-driven pattern is I'm going to come here. I don't even know where it is in my command manager anymore, Steve. I'm so used to go into my shortcut menu. So you have this pattern type called curve-driven pattern. And what we're going to do is we're going to pattern a body, okay? So we're not going to pattern a feature because I know that the distance between each of these links is 3/8 of an inch or 0.375. So I'm going to grab that body, and that's going to create a multi-body part file. I also need to choose my path, and I'm going to just expand my tree, and I'm going to grab that sketch. And then we're going to set our pitch right here. So I'm going to go ahead. What's our pitch? 3/8 of an inch. That looks really good. There is something strange going on right here. These don't quite line up. Is that because I have the wrong number of them? I don't know. Let's go take a look at what happens in the assembly when I do that. So what you're going to see here, if I zoom in down here, is this looks pretty good. But
right.
You see it right away on the first link. Notice this, Steve. Notice this little gap right here that's starting to happen.
Yeah. I see it.
And that gap gets bigger, and that gap gets bigger. Let's ask the audience, why do they think that gap is getting bigger when I do a curve-driven pattern?
Yeah, if you know why this is happening, if you've got kind of the deep cut answer to this, Jeremy's going to obviously let us know. But let's see if you can. Let's see if you guys can guess why this is happening on this design in the chat.
And you can see here when we get around to the other side, it gets really clear. Now that could be because we don't have the right number of links and we have that transition. But I really want to talk about this gap that's taking place here, and it has to do. I'll give you a hint. It has to do specifically with chains.
Okay. Right? All right.
So I'm going to start a sketch. We're going to talk about this problem right here. I'm going to start a sketch, and I'm going to do some convert entities right here. I want to tell the story better. So using all the wrong tools. So let's create an arc here. Let's make this arc and this line equal to one another to tell this story. All right, so we're going to give the answer here. Are there any answers in chat yet? There is a delay on the chat, Steve.
It looks like Gary's saying, could it be that that isn't adjusted to the proper polar coordinates? And Timborora says the circumference, pitch. Yeah, so Bocek's jumping in with pitch. So we got a couple good answers.
All right, well, let's take a look. So we set the distance to be between those two components to be 0.375 in English units, 3/8 of an inch. Let's dimension to the centers of these circles right here. And what is going on? Look at this value, Steve. That's not 0.375.
No.
So what is 0.375? Well, this distance between this center and this center, if I draw a line right here, this is what we call a cordial distance on an arc. It's the distance between 2 points on an arc. When you use a curve-driven pattern, what it's actually defining is what's called the arc length. And that's the distance that it travels along that arc before it gets placed. And this is where we come into our first hiccup here. How are we going to solve this? So does that make sense to the audience? There's a chord length and then there's an arc length. And there's two different values.
I think there's actually a really interesting tip that you just showed that you can dimension the arc length.
Oh yeah, let's talk
I don't think
about
a lot of people I don't think a lot of people know that you can drive the arc length with a dimension.
So there's a couple really cool things. There's a couple, and you'll see me do another one later. If you're you can do this in a drawing. This isn't just sketches. So when you're detailing your drawing, if you dimension to the end of an arc and the other end of an arc, and it's going to try to give you a linear dimension. But if you choose a third option, the arc itself, it'll give you an arc length dimension. Now, the reason that dialogue's popping up is these are fully defined sketch entities. So it's just telling us these are reference dimensions. Here's another tip along those lines, Steve. What if I wanted to define the angle between these two?
Oh, yeah.
You do very similar. You can go center to center And then if you pick the center of those points, look at that. It'll tell me the angle between those 2 points without having to create construction geometry.
So many good little tips.
Yeah.
Many.
So we know that curve driven doesn't work because curve driven doesn't actually have an option for cordial length. It's not necessarily meant for just chains.
Yeah.
So let's delete that. Let's look at, so now we have to like solve this. I'm going to call it the hard way. And I'm going to delete this sketch and I'm going to turn the other one back on. So we're going to leverage some other pattern types here. What I'm going to do is I'm going to start by leveraging this circle. And we all know, I think at this point, that we're not going to end up with a straight line here. And I'm going to tell you it's going to confuse me. So I'm going to delete this guy. And we'll come back to figuring out that arc later. All right. So we're going to come in here. We're going to create a circular pattern instead. And I'm going to leverage bodies here. And we're going to choose our axes. Now, you saw me create an axis there. And the reason I did that is because you can't actually use a sketch circle as your axis of rotation. So I'm going to go up to my view key, view axes, and turn those on. And I'm going to select that crank center line. Okay. Now, what I'm going to do is I'm going to say, I want to go, there's 2 ways of defining this. We have to get that dimensional value there. Well, I know I have 14 teeth on my sprocket, so I could just say equal space 14. Now that's going to go all the way around here. So how do I get rid of some of those? Well, you can actually do this option called instances to skip, because we know that I don't need that full rotation of entities.
Right, right.
Now, the other way you could do this is you could type in the problem here. You could type in 360 degrees divided by 14, and you could do instant spacing this way, and then you could come back and do it that way. There's no right or wrong way here. In fact, this way you could drive with an equation if you wanted to. I'm going to do equal spacing. I'm going to set it to 14, and then we're going to go in here. We're going to get rid of some of these instances. So we're not going to create a roller bearing in space where it doesn't belong, right? We want these roller bearings to go up this line. So let's go ahead. Let's delete these. We're just going to remove these instances. And now we get into this weird conundrum of, well, where does that curve that we're going to create later start?
Right.
I don't know. Let's just leave this here. I think it's 3, maybe 4. I'm going to leave it. Because guess what? It's parametric. We could always go back and edit it, right?
Yeah, yeah.
All right. So we've started this. Now what we want to do is we want our roller links to go up and around. So we're going to create another sketch. And here I'm going to start getting fast because we're at 11:34 right now.
Yeah.
So I'm going to draw a circle. I'm going to show you a tip that I really like here that I just learned. Well, I'll show it to you on the next one, on the next pattern I create, actually. So what I'm going to do is, for simplicity, I'm just going to make these 2 arcs equal to one another because I know that they're the same diameter. And I want to set the distance between the center of this and the center of this, that chord length or that linkage length right here. And I'm going to grab these 2 arcs, and there's something wrong with this dimension right here. And that's the vertical spacing between those. Some users have run into this, like where it's flipping around. So this is the dimension I want right here, right? I want that, that distance, but I want the dimension out here. You look at your cursor, Steve, there's a little blue icon on the right mouse button with a lock. This will actually lock that angular dimension or that aligned dimension. So now I can pull it out. Now I can go ahead and I can type in that 0.375.
I overlooked that for the longest time until I was like, why is the mouse blue? I'm like, oh.
Yeah, so we're going to go ahead. There's nothing different here about the one we did before. I'm just going to extrude that midplane. We're going to create our next pattern. So this one, we want to create a linear pattern, and we want it to stop about here where it starts to make that transition. So we're going to go ahead here. We're going to go to a linear pattern, and I'm going to select my direction. And again, we're working in multi-bodies because none of these touch. We're going to grab this body. And we're going to set that chain pitch, that number we looked at before, that 0.375. And now I have to figure out in my head, how many do I need? 6, 7. This is going to be really
I was
take
gonna
a
say
long time.
this could take a while, man. We're tight on time.
All right. Well, let's try a really cool option that came out a couple years ago inside of SolidWorks that I absolutely love. It's called Up to Reference. And maybe I don't care about how many there are. I just want them to have a spacing of 0.375 and go up to this point.
Yep.
Look at that. It automatically just figures out how many of them I need. It stops right before it gets to that point and it won't create any more.
This option like rocked my world when it came out. Like I remember back to all the machine design I was doing. I was like, where was this?
Yeah, you need to create 3 cap screw holes equally spaced along the edge of the plate, because you can do that as well. Maybe you don't want to use spacing. Maybe I just want 20 of these equally spaced along a line. And then now notice when I changed this option, it placed the last one on the endpoint, and then it equally spaced 20 of them along that line. So there's 2 different ways to tackle this problem. We want the pitch to be the defining factor here, though.
Right.
All right. So we've created our next pattern. So we've used a circular pattern, then a linear pattern. Guess what? We're going to create another circular pattern. I'm going to show you some really cool ways to sketch quicker when you're doing circles like this. So you saw me grab these 2 arcs and make these, equal to one another, and then I manually added a dimension, right? So I went equal. Look at this. Just like X Design on the 3D Experience platform, in SolidWorks, we added this auto add dimension. And guess what, Steve? It does the align dimension type. So I can just click this and then type 0.375, and look at me, I'm done. Let's go ahead. Let's extrude this and get on our way. Pretty cool tip right there.
That is awesome. Hey, real quick, we had a question from Dallas. He's saying that there's no curve-driven pattern for sketches, only features.
Correct. So what he's talking about is, so say I'm in a sketch. So say I start a sketch and I wanted to. So we have sketch-driven patterns as well. We only have linear and circular patterns for sketch-driven patterns. And we're going to use circular-driven sketch pattern here in just a moment, actually, but. That's correct. There is not a curve-driven pattern within the sketch environment.
Got it. Okay.
So here's where I'm going to go ahead and, again, we're going to use this axis that I have. We're going to do the bodies. It's going to start to feel a little repetitive. But this time, so last time we did equally spaced. There are 28 teeth. So if you don't know, a cam has to move at half the ratio of the crankshaft. So we use a 2-to-1 ratio. So I need double the number of teeth on this sprocket. I don't really want to go through and do instances to skip on all these. So this is actually where I was going to reveal. You could actually just come in here and you could do 360 divided by 28. And then we're just going to do this. Let's turn off instances. We're just going to change this number. And again, this arc right here, so this is where it gets a little tricky. I want this roller pin to fall on this horizontal line right here. So we don't want that sketch entity.
Yep.
So you've seen 2 examples in a circular pattern. You can do equally spaced, or you can do the traditional driven, but you can type in equations in there to do that. I'm going to go ahead and we're just going to add the next rollers. Don't add any new tips or tricks. So I'm just going to be really fast. You're going to see me do this thing again where I go equal, auto insert, type it in. And then here's the cool.
Go ahead.
So here's another cool tip. If you have instant 3D turned on in your features, if you're in a sketch, I don't know if you know this, you can just double click in the background to exit the sketch. And then you can, that'll keep that sketch selected. Hit extrude, right click mid-plane, and then watch this. Here's my mouse gesture. How fast is all of that?
It's amazing. Lewis does say, he chimed in and said, this live stream is amazing. Take your time, please. So I think you've got some fans.
All right, cool. So we're going to do what we did before here. We're going to do an up to reference. So watch, see how right now it's just throwing these out indefinitely. We're going to do an up to reference up to there with our 3/8 of an inch pitch. We're going to go ahead and we're going to hit OK. And then we're going to do our last arc. Again, nothing really new here, except for we're going to have a thought step that we're going to have to go through. So let's do this again. I love this tip. right here, this equals, and this auto insert dimensions. So that's an example of where we had something on one of our X apps. We brought it over here into desktop, and I absolutely love that. You know what I wish we had in desktop that we have in X Design, Steve?
What's that?
You know how I'm making those circles equal to each other all the time? Have you ever done the thing where you can sketch in X Design and you just touch a circle and you can make them equal just by touching another circle? Have you ever used that?
So cool.
Oh, it's so cool. I love that. All right, so let's go ahead here. Circular pattern. We're going to grab our center line. We're going to grab our bodies. I'm sure this is getting a little redundant, and we're going to go flip our direction. What is going on? I grabbed the wrong thing. I grabbed the chain path. There we go. And again, we're going to set our value to be 360 divided by our number of teeth. And here again, we're kind of stuck with this, like, how far do I need to go? I don't know. That looks pretty good, I guess. I'm guessing. So here, I wish I could tell you I had like just a raw mathematical formula for like how to figure this out. And I'm guessing you could with some crazy trigonometry, but I don't want to bust out a calculator and do math. I want the software to solve this problem for me. So this is where we're going to look at solving probably the hardest part of this. I'm going to open up, just for reference, I'm going to open this up so everybody can see this again. We're going to figure out this arc, how it comes off of those sprockets, and how to get that arc to be nice and smooth in its transition.
Yeah. I've been wondering how you're going to tackle this.
All right. So we're going to start a sketch again on our front strand center, and we're going to go ahead and we are going to draw an arc between these two pitch diameters. Remember, these are pitch diameters, not like the outer diameters. We're just going to make these tangent to one another. Now, you know, the first thing you could do is be like, well, you're just going to throw a radius on there and guess? We're going to do something a little bit different here. I am going to draw my circle. And this time, I'm going to make it equal. Now, I don't know how many of these I actually need here. So I'm going to grab one that I know I'll never delete. I'm never going to delete that circle. I'll make that equal. And what I'm going to do is I'm going to start with this arc. Ooh, before I do that, how many roller links do I already have in my design here, Steve? And I cheated. I kind of moved my cursor there. You know, an easy way to tell how many pattern instances I've created already?
I'm gonna let you reveal it. I do know.
Okay. So it's actually over here, because we've been multi-body. Every body represents a single roller. Yeah. So I know that I have 71 bodies in here. And what I'm trying to avoid is what is called the dreaded offset link. I don't want to create one of these guys right here. I don't want to create an offset link. I want to have an equal number of links. And that means I need an even number of rollers in my design. Okay. So that means that I have 71 rollers already. That means that I need an odd number of additional rollers. So keep that in mind. What we're going to do is we're going to add our dimension. We're going to add our pitch, 0.375. And now I need to create a whole bunch of these. Now, I'm going to make this construction because I don't want it to get in my way. So how am I going to do this? Well, sketch patterns. We just talked about sketch patterns. I'm going to create a circular pattern. And I'm going to give you a pro tip here, Steve. I'm going to actually select what I want to pattern first. And the reason I'm going to do that is because if you select the center first and then you select that arc, it'll change what it thinks you want the center to be.
Oh, yeah.
I'm going to grab this, and then I'm going to go grab the center of that arc that we just drew. And I don't want to use equal spacing because I don't want to have a bunch of circles in a row. So I'm going to go to dimension the angular spacing. And I know it's not 90 degrees. Let's start at 5 degrees. And now these previews are going to be a little bit hard to see. That's clearly too much. So let's just get this close. 2 degrees, that doesn't look like enough. 1 degree, that might work. And then how many do we want? I don't know yet. Let's just add some. So when I specified on a sketch-driven pattern that I wanted to use an angular dimension, it did just that. It added 2 pieces of construction geometry, and it added an angle. Now I've got to figure out what this angle is. That's just as hard as figuring out the radius of the circle. I don't want this. Let's delete this. You're probably going, why are you deleting what SolidWorks did for you? Well, so here's what's happened. Even though I deleted that angle, notice that all of these arcs still act in a pattern. In fact, if I turn on my sketch relations, you can actually see that they're instances of a pattern. So again, I have a hotkey, Shift R. Otherwise, you could come into here and you could go to, I'm not actually sure where it is. It's somewhere in here. I use a hotkey, so I forget where I put, right here. Here it is, the symbol right here. I've used hotkeys for so long. All right, so what I'm going to do is I still want these to follow on these arcs. So this is pretty cool. I'm going to select one instance in this arc, and I'm going to make their centers coincident. And it looks like it's pretty close, but it's not quite on. So what I'm going to do is I'm going to grab a third instance, and when I make these coincident, they now all will follow that curve.
Oh, nice. Because you deleted the angle, but the instance count and the relation is still there.
And here's how I'm going to get the curve length. I am going to dimension the distance between two of these. I'm using the curve and the pitch. And now those are equally spaced along that curve. So all I have to do now is increase my number of instances here. So what I'm going to do is I'm going to right click on this. Now I could come up here and I could double click on this number and change it. But I'm going to show you a way to get back to a sketch driven pattern. If you right click on any instance in a pattern and you go to, you can do edit circular pattern. And then I can just come in here and I can just go, well, let's get this till this looks about right.
Nice.
So we want to get this about there, looks pretty good. And how many is that? 33. So I have an odd number, an odd number. This looks like this might be pretty good. All I have to do is put a dimension between here and here. And I don't want that vertical. So here's where we're going to get it. This is where it gets tricky. So I'm going to watch for that dimension to change. See how it changed very briefly. And then we're going to make that. I did that right click thing. Oh, no, it's not going to work. Why isn't this going to work? Well, guess what? 33 instances isn't enough no matter how hard I try to get that within 3/8 of an inch of that other roller. Okay, so that's a problem. I can't get that close enough. That means that I actually have to add some slack into here. Okay, so let's go ahead. Let's edit this pattern again. And now we know that we want an odd number. 33 is not enough, so let's just go to the next one. Now this looks like I have way too many, right? Like, oh my goodness, that's horrible. Like, I don't want that much. So this is where you have to kind of do a little bit of like thinking, like tinkering around with this. Like, how many do I want? Well, what can I do here? Can I shift where I start and where I end? Like, can this one come down to here? Because like if I come in here and I dimension, and I'll be honest, this is like where you spend a lot of the time kind of solving this problem. Actually, no, I think I got it just right. I did. Okay, never mind. So originally this is good because we're short on time. Originally what I was going to do is I was going to have the wrong number of links, and I just guessed. It looks like I have it right, because what you want to do is you want to make sure that the first link is on this arc.
Right.
If this link was out here on this circle, that meant that you had the wrong number. And again, for the sake of brevity, I'm going to just say, guess what? We did it right the first time. I don't feel like I did.
Listen, we're engineers, we're SolidWorks users. Of course we did it right the first time.
Yeah, for some reason that number doesn't feel right to me. But anyway, let's go ahead. Let's extrude that.
So real quick too, we got an interesting comment in the chat saying that we need a showdown between you and Too Tall Toby.
Toby
going head to head.
Toby would kill me. He's so good. Toby's the best. He's like
you guys are both amazing. I would probably pay money to see that as well. So
so here we have our chain profile that we want to work with. Now at this point it gets really boring. I'm going to be honest. What we're going to do, if we wanted to model this whole chain, we would basically start modeling the chain links. And I would basically use the same techniques we've seen already. And so you know that this, I'm just going to type in this number. If you look on that chart, it's, oh, it didn't take. The width or the height of these links are, strangely enough, 0.95 times the pitch. And we're just going to put that in there. And what we would do is we would start adding these links. Now, one of the things you're going to do is I want to get to the assembly portion of this. We would add this link and then we would pattern those around. We join them all up. But what's going to happen is you're going to get to this arc and you're going to run into a similar issue. How can we take advantage of this pattern right here? Well, what we could do, you saw it earlier when we were creating reference dimensions. If I come in here and I edit this sketch, what we can do is, remember the angle that we deleted, Steve?
Yes.
I'm actually going to go back in and I'm going to add the distance between two links here. Not two links, but distance from one to the next, one instance to the next. And we're going to add an angle, and the sketch is fully defined. So what it's going to do is it's going to tell me that this is a driven dimension. No, you know what? I did that wrong. I want the distance between two links. I'm going to go from here to here. And here's that tip again, dimension to the two centers and to the centers of the two endpoints and then to the center. And you can get,
yep.
Yeah, something's wrong here. I don't have the correct number. Anyway, we'll deal with that in a minute. So you would eventually get to a point here where you would have to create a pattern here. And I'm skipping creating the rest of this. And we're just going to throw a dimension on here.
I think while you're doing this, the thing I love about the driven dimensions is that, of course, they show you the value that it's there, but that then becomes available to put into an equation or to reference in any number of different ways. So even though it turns yellow initially, it's still really, it can be really valuable.
That's exactly how we're going to use this, Steve. I'm going to go back. I got to get this sketch. I'm going to show it. I'm going to try to go fast. We're going to add one of these axes here really quick. Because that's what we would have ended up doing when our link got around to here. We would have ended up creating a circular pattern of this feature. Now we can use features because they start to join. We would have chosen this axis and we would have been presented with an option like, what's the spacing? Well, I saw it was like 1.5 or something like this.
Mm-hmm.
And yeah, I actually needed to go the distance between three links. Whatever, that's fine. What I can do is I can actually double click on this pattern. So patterns are one of the things where you can't actually, the way you access the dimensions are a little harder, but I can pull this dimension out and I can actually, if I could double click on it, I could drive an equation here. So I could go equal to, we're going to say this value times 2, hit OK. And I hit rebuild. Look at that. Now all my links are done. And then all we have to do is like change the number of instances we have here, maybe like 14. Boom, we would figure that out. Right. So we would continue along here. I'm going to close this for right now. And we're going to pick up. We're going to do Martha Stewart style here. I just did not save that. I literally just said don't save that. That's fine. We're gonna we'll do this. We're gonna unsuppress the one we have done right now. So basically, I would use patterns in that same fashion to drive around, and you can see I create a whole bunch of patterns, pattern it around, and then what we've done in that whole process is we've created half of a roller link. Yeah. So then all we have to do at this point is, again, here's that plane that we were sketching everything on. I'm gonna go ahead. Another type of pattern is a mirror. We can actually mirror bodies and say, you know what, merge these together. And you'll notice here that I went from 106 bodies previously to it's one now. It's one body. In fact, we can mirror that around our front plane because we mated it in the assembly in the appropriate location, and we can merge those together now.
Right. So it's actually doing the Boolean, effectively doing what we used to call the Boolean operation between the bodies. Got it.
Absolutely. So one thing I want to do here is I'm going to turn on some sketches really quick in my rollers. They are on. Let's just turn them on. I'm going to turn on that sketch and this sketch because we're going to use these. We're going to get into the assembly. We're going to probably run over a little bit. Is the audience okay with us going over a few minutes?
Let's have them fill it in the chat. My suspicion is they're going to be okay, Jeremy. So I just would keep heading ahead and keep on trucking.
So this is great if we want to create like this fixed position assembly. But everybody at the beginning saw we had motion in there. Oh, I forgot about one of the biggest problems in here. And that is the sprocket. I forgot all about this. So if I roll back in my part design to just the rollers, guess what? They don't line up perfectly. There we have a bit of a problem. Well, there's a reason this actually happened this way. When I originally mated this sprocket to this camshaft, so if I come in here and I look at this camshaft, you can see here's a mate. I said make that camshaft and that sprocket parallel to one another. Let me go to front view here. Well, at the end of the day, I need this location to line up with one of these pin links.
Yeah.
So what we can do here is I'm going to suppress this parallel mate, and I've added some top-down assembly sketch relationships between these keyways. So check here, watch when I click rebuild. So notice how my keyway updates, right?
Yep.
So what we're going to do is we're going to align this to this entity right here. And I'm going to basically just grab the right plane here, and I'm going to turn on my temporary axes. So temporary axes are these axes that are created on every cylindrical feature in your file. And I'm going to select the center of that arc. That sketch is getting in my way. I'm going to make those coincident to one another. Look what happened. My keyway lined back up. So now I have a proper keyway of my camshaft that matches my sprocket.
Right.
I'm going to do the same thing over here. I don't want to dig for that sketch. Look how I'm going to do this one. I'm going to use these breadcrumbs again that we saw earlier. But press my D key. I'm going to go to my assembly and look, here's, oops. I'm going to come up and I'm going to select that parallel mate and I'm going to suppress that.
And this is really the power of top-down design, right? Because what you've built into this is the fact that that shaft isn't rotating. What you need to have rotate is the keyway itself to ensure that it stays lined on the cams, right?
Yep.
Yep. Okay.
So now we have everything lined up, and now I can come in here and I can edit this part, and we're just going to tell it to roll back, roll to end. All right, so we finished our chain design, but we want to see how we do it in an assembly. Well, we're going to cheat. We're going to steal that profile that we used on this chain to drive our chain in our assembly. So I'm going to start a sketch, and we're actually going to use top down the opposite way. We're going to, I guess you could say, go bottom up a little bit. I am going to come in here, and I'm going to turn on some sketches, and we're going to grab this sketch. We're just going to say convert all the entities, and we want that sketch for that roller profile right here. Now, I don't want that whole sketch. I just want that arc right there. I don't want all those circles. So we're going to, again, do convert entities. And I'm going to exit the sketch so I can now hide this so you can see what's going on. So if you look, this sketch is kind of where we were trying to get before. I'm going to edit this, and we're just going to trim some of these entities. I'm going to trim this entity, this entity. So basically, that is a trace of where our chain is going to go.
It's just living inside of the assembly, at the assembly level at this point. Got it.
That's our chain path.
Okay.
And I'm actually going to suppress this guy right now, because we're going to show how a couple things are going to get unlocked. So now we're going to get a little bit crazy here. We're going to take all these mates off that were created. The problem is because I've done this, look what happens here. This thing is free to move around, and that could be a problem. So I'm going to undo that movement because I want these two to actually move together. So when I come in here and I turn these mates off, right now these two don't move together. That's a problem, right? Because in fact, if I click rebuild, look what's going to happen. It's just going to keep updating that keyway.
Yep.
So let's undo this. Oh no. I can't undo that apparently. So let's unsuppress this and let's unsuppress this to get everything back to that home position. So now they're all back. What I'm going to do is I've got the keyway defined. I actually don't need it to update anymore. So what we created was an external relationship. I'm just going to right click on this feature, and you'll see under this feature, I have the external references on that cut extrude. I'm going to lock those. I don't want them to update anymore.
Yeah.
Right click, I'm going to lock this one. I'm going to right click, I'm going to lock this one. So locking external references is if you're scared of top-down assembly design and things changing like what we just showed, you can use it to create your geometry and then go back and lock it, or go into the sketch and fully define it after the fact.
Yeah, I was just going to say, I think this is one of those things where people get really hesitant of top-down design, but if you know a few of these little tricks, it's actually it makes life so much easier, and you get to benefit from all the powerful capability that it provides.
Absolutely. So now when I suppress this, what I'm going to do is I'm going to mate these two components together so that they move together. I'm going to mate these two components so that they move together. So now they're always going to rotate together. So the sprocket drives the camshaft. Now you might be going, cool, now you're going to use the chain to drive this. Well, I'm actually not. I'm actually going to use a different type. I want to create this. Let's create the chain pattern because we're over on time right now. No, I'm gonna do it the way I was going to do it. We're going to hide this guy really quick. The way I'm going to keep these in sync actually isn't going to be with a chain pattern. Now you can do this two ways. I talked earlier in assemblies, we actually have a feature that helps you create belts. So say I wanted to create a belt here, you could create a belt or chain feature. And what this will do is I can select, though it's maybe you don't actually want to design the chain, you just want to capture the movement between these two components. I can select those pitch diameters, and when I do that, there's an option here called Engage Belt. And when I do this, I can go ahead and press OK, and now all of these components, oops, I got to so it gave me an error because it's trying to drive it, but yet I'm not allowing any of the components to move, so we'll suppress that. So I've already got that motion. So that's all you really needed to do at the beginning to get to there. So another way you could do this is not with the belt feature, because this belt feature is cool because it gives you the length of the belt.
Right.
I actually want to do this with mates. I want to use mechanical mates myself here. I'm going to come in and we're going to create gear mates. Now, gear mates in my last live design where I did gears were for meshing gears. Well, these can also be used for pulleys or timing chains. All you have to do is choose this reverse option. Now, the ratio, you'll notice, it automatically captured the diameter of those pitch diameters. And that's why pitch diameter is so important. That's actually what's defining that ratio. I know it's 2:1, but here I'm just going to let it grab the value that's already there.
Right.
And as soon as I do that, look, these two components now move at that 2:1 ratio right there. So let's just add.
Jeremy, do you have a reason why you tend to use one over the other?
Why I use a gear mate over that belt chain?
Yeah.
Because the belt chain actually creates kind of a more complicated feature in the feature manager tree. It can over-define the assembly more. You'll notice this. So remember when this mate was unsuppressed before, I had an error. I don't get that error with the gear mate.
Right.
That's
okay.
why. It's more, that's a heavier feature. I think creating two gear mates is a little more lightweight, and it gives me a little more flexibility. Like maybe I want to cheat and I want to say, actually, I don't want them to be 2:1. I want to look at what a 3:1 ratio might look like. I could come in here and manually change these values.
Oh, right. Okay.
Where with the belt pulley, you can't do that. So, so we're back here. Okay, we're unsuppressed. Everything's moving. Everything looks good. Last step. Let's actually lock everything down really quick. We're going to build our chain. So I'm going to go ahead. I'm going to insert these two components, this roller chain and this roller link. Boom, boom. And the chain pattern, the chain mate is actually not a mate. I've been calling it a mate. It's a pattern. And it's actually a super powerful pattern. We're going to turn this sketch back on. And it's a pattern that can automatically instance components around a sketch. And it's super powerful how this works. So we're going to go up to our patterns, and you're going to see this chain component pattern. And you might be wondering, well, don't you want to pre-locate these components? The answer is you actually don't. If you add too many mates to chain link components before you add the chain component pattern, it can cause some over-defining issues. So I'm going to give you a couple tips here on how to get things positioned just right with the chain pattern. So the first thing you could do is you could pattern individual components. We could do a distance linkage, which was added in SolidWorks 2020, where we could set a distance between each individual component. And basically, here's how you create a chain path. You choose a path, and then you choose your component you want to pattern, in this case, our rolling link. And then what we're going to do is we're going to choose where the first linkage is and the second linkage is. So that's what these little icons are here. We're going to grab our first linkage, our second linkage, and then what it needs is it needs a plane that's going to be parallel to that, or it's going to be coincident to that chain sketch. Okay. Well, these parts happen to be designed with their front plane right down the middle. Every live design talks about origin placement. Here's another good example of why you want to start. You want to design things in the appropriate location in that component. As soon as I do that, look what it does. It starts patterning it. And I can create a couple instances. Now, this is distance linkage, where I can set a distance between each one of these components. In this case, 3/8 of an inch. I want to actually do this mate, a connected linkage, where it's going to ask us if it can just connect those one at a time in case they were transitioning links, or we can add a second chain group. And in this case, I'm going to grab this component. And just like before, we're going to grab our first linkage spot here, our second linkage spot. And again, we're going to grab our front plane. And notice how it automatically starts patterning that component. And we could go in here. We're going to come back to this. I want to talk about getting this lined up and why didn't I do the full pattern right away? And the reason is I want to get this guy located on this first linkage right here. Everything else in my design is fixed. Nothing else is moving. I'm going to add another mate that I want to use for kind of reference. I'm going to make these two concentric to one another. And I totally did that wrong. I want to actually come in here and I want to click the mate icon. Now, the reason I want to click the mate icon as opposed to just making them concentric is sometimes you want to use a mate just to put components in position. And there's a checkbox down here called use for positioning only. And when you use this, it'll honor the mate, it'll move the component, but it doesn't actually create the mate in the feature manager tree. So that part, I could drag it right now, but I wanted to get everything lined up really nice. Now I could have created a concentric mate and kind of put it up here in my favorites as like a locking mate. I could have done that as well, but I wanted to show people for positioning mates.
I think that's a huge little tip, because that's another one that I used especially if you're a machine designer, you're doing this kind of stuff. The mates are so powerful to just get things where you want them, but you don't necessarily want to commit to it, right? And so that option is so handy.
Use it all the time with a lot of moving parts. Andrew Gross, the guy running the stream on the back end, he did a really cool live design episode where he talked about locking components while he was mating too, fixed groups, which is really cool. And that was where he was designing that bike suspension. I really recommend watching that. But okay, so we need to finish the pattern. Just like what we did with the linear pattern, I don't want to figure out how many I need. There's a really cool option right here just called fill path. Now that I've got it all located, I'm just going to hit OK. And there is my chain. Now, here's the problem. This chain isn't tied. It moves. I don't know if you can see that moving. Here, let's undo this. I'm going to make it really obvious where this is moving. We're going to take that first component, and I'm going to just grab some candy apple red, and we're going to drop that on just that instance so we can kind of keep an eye on that. I want this chain. So these components move. No, they don't. I have them suppressed right now. For that, I have them locked. These components move freely. So I can see that I have that motion. You're going to see me undoing so that everything goes back to where it was. And the chain moves separately. So how do I make them move together? Well, we're going to use another type of advanced mate. And I will tell you about the limitation that comes to this mate. We're going to use, what is a type of mate that allows rotation and linear motion?
I'm going to say rack and pinion.
You are absolutely right. So we can use the rack and pinion here, and we could do, we can do every number of revolutions. How far does the chain link move? That sounds really hard to me. Guess what we're going to use again? Look at this, pinion pitch diameter. Yeah. Hopefully everyone's learning how important pitch diameters are in
yeah, it's huge.
And we're going to use for our rack, for our pinion gear, this is really easy. We're going to turn on my sketches, my hotkey, and I'm going to grab that pitch diameter. So I'm going to grab that. Now the rack is the tricky part. There is currently a limitation where SolidWorks doesn't like the rack to go past a certain, I don't know how you want to say it, past a certain linear motion. So what I'm going to do is I'm actually going to grab one of the chain links up here. And that's why I have these sketches turned on. I'm going to just grab, I'm having a really hard time grabbing it. So we're going to do this. We're going to right click. We're going to do select other, and hopefully I can grab one of those center lines. So select other. This is another tip. If you have a bunch of edges on top of each other, this is a way to grab like an edge underneath another edge. We're going to grab that line. You see it thought there for a second about how's this going to work. We're going to hit OK. And now I'm going to cross my fingers that I did everything right. No, I'm pretty confident in this. And we're going to grab a hold of this. And you can follow the red chain link as it goes around here. So we have gear mates driving basically the drivetrain, but that rack and pinion is what is driving our chain along that motion there.
That is so cool.
So, but what you will see is it'll get to a certain spot where it's about when it's going to cross this threshold up here. It doesn't want to go anymore. So I'm not going to, and that's just, there's like some weird limitation with a rack and pinion mate. It was really made for a rack and pinion, but you can get away with using it here.
Sure. Yeah.
Just keep that in mind. So pretty cool. I'm going to undo this, get it back to the beginning. Anyway, that is it. We went way over. We went 15 minutes over. I appreciate everybody's attention, staying with us. Hopefully, this was enjoyable for everybody.
I think you had a huge amount of fans very impressed, Jeremy, myself included. I think we all learned a few things. You definitely did some deep cuts on some of those.
Yeah. This was a more intermediate to advanced topic for sure.
Yeah, but I think this is huge because along the way we all picked up a few little tips that are just super helpful to make those things happen. So we all, on behalf of the whole audience, thank you for the time you put into this and for the information you shared. As an audience member, thank you for hanging out with us today. We're going to be back next Thursday. We're here every Thursday. Next Thursday is going to be Exploring 3D Experience Works with John and Gian. You're not going to want to miss that one because we're going to go over some of the basics of revisioning for the design process. It'll be a great session you won't want to miss. We'll be back the following week with another live design, just like this one, where a colleague of ours, Juan Chapa, is going to walk you through some tips and tricks for sheet metal. So be sure to subscribe and turn on the notifications so that you get notified when each of these happen. And again, we just are grateful for the time you spent with us today. And again, huge thanks, Jeremy, for all the cool tips you shared.
Thanks for having me. I had a great time.
All right. Thanks, everyone.